Hey everyone, this is Tyler Berry back for another whiteboard session. Today we're going to be focused a little bit more on piping itself and thermal expansion. It's not something you come across too often. A lot of times we see it in high pressure steam piping, condensate piping, but it's something to be aware of even in hot water systems or chill water systems of a certain size, whether it's expansion or contraction. I drew just kind of a quick little table over here just so everybody has a frame of reference for a temperature, how much pipe actually expands. And this is why I say a lot of times we have to contend with it with, 125 pound steam, which would be in this range of almost 2.5 inches per 100 feet. But we still have to contend with it in our hot water systems, domestic hot water systems, things of that nature. So traditionally, we try to handle expansion with what we call hard pipe loops, whether that's a true hard pipe loop like this, a dog leg, or what we would call a Z-bend. So in this example, a 6-inch pipe with 4 inches of movement, this hard pipe loop is 6.5 feet by 13 feet. For a dog leg like this, it's 33 feet on that leg. And for a Z-bend, you're 21 feet all the way around. That's a lot of space to incorporate, and a lot of times, that's why I say this 4-inch movement is an extreme example, but a lot of times we have an inch of movement, 2 inches of movement. We have to handle that somehow, and do you have the space for these hard pipe loops? Alternatively, we do have these things by Metroflex called a Metro loop. So this is an example where we get a flange or welded in connection, and we can accomplish the same thing as this hard pipe loop with 24 inches by 36 inches. Now we also recognize that in some instances even that's hard to fit in a tight ceiling corridor or something like that. So sometimes we have to do a slip joint or something like a bellows. But another great benefit of doing something like a Metro loop is the anchor load. So whenever we're dealing with expansion, we have to anchor and guide. We have to have a start point and end point to our expansion, and we have to guide the movement into whatever is compensating for that expansion or contraction for that matter. So when you use a Metro loop, the anchor loads for this example, 6-inch pipe, 4 inches of movement, it's 202 pounds. If you do a bellows type joint, it's 12,800 pounds. Your structural engineer has to account for that. So just keep that in mind when we think about thermal expansion in general. Also just keep in mind with Metroflex that there's all sorts of custom configurations. Whether you don't have space for this, we have to do a 45 V-loop. We can do a dog leg like this and shorten up these distances like that. We have metrogators, we have a lot of seismic rated things. So even if you have a question about seismic stuff, anchors and guides, supports, how to just lay out this system, delegated design services, reach out to us at TLA. We'll work with Metroflex and you all to come up with the right solution. So I hope you learned something, and thanks again.